So what we shall do, because they have different bases, we cannot simplify that one further. So what we shall do is I'll say, what is 2 to the power 9? 2 to the power 9.
512.
512. What about 3 to the power 6?
729.
729.
Right.
Okay?
Yes. Okay.
You can leave your answer in power form or you simplify like this. There's no problem with that. All are still correct. Okay?
Yes, teacher.
Yes. It's not a must that you must simplify it to this. Okay?
Okay.
Members, if that one is true, now let's go and see how we use indices to solve equations. To solve what? Equations. How do we use indices to solve equations? How do we use indices to solve equations? But before we move to that, I want to give you one more question on that. There's a question I want to give you on dealing with negative powers. How we get the reciprocals, okay?
Yes, teacher.
Let me check for one from my phone here. It's not on the screen, please. It's not on the screen. Let me just check for one from here. The question is here. Simplify. Okay? More examples. Now we are on more what?
More examples.
Simplify. I have 16 over 81 to the power negative 3 out of 4. Simplify for me that. I'm waiting for the answer, please. Work out that one.
What is 16?
16 is 2 to the power 2 to the power what to get 16. Which is 8 part you get 16. 4 to the power 4 you get 16.
Yes. Yes, members. Members.
Yes.
Alpha.
Almost done. Then to get the reciprocal, you have to change it. 3 power 4, 4 power 2. So the outside now changes to 3. Then 3 times 3 out of 4.
Yes, Alexandra.
By
Yes.
2,
Yes, Alexandra.
I've got 3 to power 3 over 2 to power 3.
This is what for Alexandra. Alexandra, you got 3?
3 to power 3
over
2 to power 3.
2 to the power 3, which is the same as 2 to the power 3 is 20. Then 2 to the power 3 is 8. Right?
Yes.
Members, are you all getting this answer? This is the answer. Have you all got this?
Yes.
Very good. Very good. Very good. You people, you are bright. You people, you are bright. You are bright. Another one. Another one. Number two. Number two. Number two. Question 2, we have simplify. Simplify. We have 16 to the power negative a half plus 32 to the power negative 1 out of 5 minus 8 over 125 to the power 2 over 3. To the power 2 over 3. Are we there? Members, have you seen the question?
Yes.
Okay. Let's go through it together. Let's go through that one together.
Excuse me, teacher.
Yes.
32 is to power what?
Eh?
What negative what?
16 to the power negative a half.
Then 32 to power
Negative 1 out of 5. Okay?
Yes.
All right. So we shall start by breaking them. We have 16, we have 32, we have 8, then we have 120, 25. So you start by breaking them. So you start by saying 16 is equals to 2 to the power 4. 32 is equals to 2 to the power. Not so. Who has forgotten how to get these powers? We still remember, right? How we get these 2 to the power 5.
Yes.
Then we have 8. We know that 8 is the same as 2 to the power 3. And 125 is the same as 5 to the power
3.
To the power 3. But now when you look at this one, are you seeing 16 and 32? They have negative powers. They have negative what?
Powers.
Powers. So if I want to remove the negative, what should we do? We have 16 to the power negative a half plus 32 to the power negative 1 out of 5 minus 8 out of 125 to the power 2 out of 3. So if I want to remove this one, I have to introduce, I have to get the what? They are reciprocal, right? So that I remove this negative power. Okay? Are you together, members?
Yes, teacher.
So what is the reciprocal of 16? The reciprocal of 16 is the same as 1 out of
1 out of 16.
16. Now, this time we have got the reciprocal members. So the power will become a positive. Plus, for 32 will become 1 out of 30. 32 to the power 1 out of 5 minus. Now, when you look for 8 and 3, the power is positive. So we don't need to get the reciprocal of this because their power is already positive. Okay? 8 out of 125 to the power 2 out of 3. So, so shall say 1 out of, we know that 16 is the same as 2 to the power 4 I have plus 1 out of 2 to the power 5 minus 8 is the same as 2 to the power 3. 5 is, 125 is the same as 5 to the power 3, but all of them is to the power 2 out of 3. Okay? After that, we start distributing the powers. We start distributing the powers. So you find that this one will be 1 to the power half. And then 1 raised to any power is still that 1, not so. Even if you have 1 to the power millions, it will still remain 1. Okay? Are you together, members?
Yes, teacher.
Yes. So which means there we shall have 1 out of 2 to the power 4 times what? A half. Okay? Plus 1 out of 2 to the power 5 times 5. Minus 2 out of 3 times 2 out of 3 out of 5 to the power 3 times 2 to the power 3. Are we together there?
Yes.
So what do we get here? Here we shall get 1 out of by 2, 1 by 2, 2.
So
So we get 2 to the power plus 1 out of this 5 will go out with that 5, remain with 2 to the power 1, right?
1.
Minus into, you will see that this 3 will move away with this 3, then we remain with 2 to the power
2.
to the power 2. This 3 will also go out with that 3, then we remain with 5 to the power 5 to the power 2.
2.
Okay? Now when you look at this one is 1 out of what?
4.
Plus 1 out of 2 minus. So this one, there's nothing else you can do here. You can simplify it further by what saying 2. What is 2 to the power 4? I mean 2 to the power 2 is it? 4. Then 5 squared is it? 20?
5.
What? 25. So what do we do from here? This is fraction. We get their LCM, right? Not so.
Yes.
Can you go ahead and simplify that? Can you go ahead and simplify that, members? So we have 1 out of 4 plus a half minus 4 out of 20, 25. So what is the LCM? What is the LCM of 4, 2, and 25?
100.
Is 100.
100.
So the LCM is 100. So 100 divided by 4?
50.
100 divided by 4?
25.
25 times 1 will give us 20. 5 plus 100 divided by 2
50.
times 1
50.
50.
minus 100 divided by 25. We get 4, right?
4.
4 times 4. 4 times 4.
16.
16. So we have 25 plus 50, which will give us 70
5.
minus 16 over 100. What is 75 minus 75 minus 16? What do you get? We get 50.
59.
59.
59.
So 59 out of 100. Is there a common is there any common factor there? Remember, is there any common factor there?
No.
No. So we leave it like that. Okay?
Yes.
So our answer is that. That is our answer. That is our answer. Let's do one more on that and then we move. Number 3. Number 3. Because the more equation we do, the more we become easier for us, okay?
Yes.
Simplify a half minus into bracket 25 over 4 to the power negative a half. So who is going to take us through this? I want someone to volunteer and take us through this question. Someone to take us through this question. Yes? Yes, Andrew. Andrew? Andrew, can you take us through this question? I want a boy now. I want a boy. I want a boy. Yes, Andrew. What should we write? What would be our first step? I have dormant boys who are dormant in this class.
It will be if is
Yup. Okay. Since boys are dormant, Lynette.
Yes, teacher.
Take us through this question. Boys are dormant. You challenge them.
Out of 25.
So shall have? We have 1 out of 2, not so?
Shall have 1 out of 2 minus minus 5 squared.
5 squared.
Out of 2 squared.
Yes, I'm waiting.
And negative half.
Negative half. What should we do to remove this negative power here?
We divide with the reciprocal.
We get the reciprocals. When you get the reciprocal, what do we
The
get?
reciprocal.
So shall have a half.
2 squared.
2
A half
squared.
minus 2 squared. Out to 5.
Now this time the
5
power.
out of 2.
Good. Next. What's the next step?
A half minus
Into.
into 2 square times a half.
Good.
Times a half. Divide by 5 times a half.
Times a half. Perfectly made. Proceed.
When we divide the common equals to a half minus
A half minus.
1 minus
2 to the power.
2 to the power 1 out of 5 to the power 1, which is the same as 5 out of 2.
So this one is the same as a half. Is the same as a half minus 2 over. Not so.
Yes.
What do we do from there now? What do we do from here? What do we do from here?
Get the
Okay,
LCM
Very good. What is the LCM of 2 and 5?
of 10.
10. Good. So what should I write here?
10 divided by 2. 5.
5
5.
Will give us
5 minus
minus
4.
minus what?
4.
Excellent. What is the final answer now?
1 out of 10.
1 out of 10.
1 out of 10. Excellent. Excellent. Boys, have you seen? Boys, have you seen? Andrew? Andrew? Andrew, can you appreciate Lynette? Can you clap for Lynette? Jordan? Lucky? Lucky? Lucky Jordan,
Yes, teacher.
can you clap for Lynette? Because I gave you the work, you refused to do it. Can you clap for her?
Thank you, Lynette.
Okay. Okay. Members, I think we are together on that, right?
Yes.
All right. Now, let's go and look at problems, solving problems, or solving equations, subheading, solving equations, involving inequality, indices. Solving equations involving what? Indices. Are you together?
Yes.
We are saying, write down this, to solve equations, involving indices, take note of the following. Take note of the following. Number one, if I have a to the power m equals to a to the power n, then m is equals to n. Okay? Are you together? Members, are we together?
Yes.
Yes. You're saying that if I have a to the power m equals to a to the power n, why are we saying that they are equal? So what we do, if they have the same base, we equate the powers. We equate the what?
The powers.
The powers. That one happens if they have the same base.
Base.
Good. So whenever you are solving equation involving indices, our purpose is to strike until we have the same base. Are you together, members?
Yes.
Provided both the bases are positive numbers. Provided all the bases are positive. Are positive what? Are positive numbers. That's the first thing we have to take note of. Then number two is to express both sides of the equation, with a common base, and simplify. Are you together, members? Are we together?
That also keeps making.
Members, are we together?
Yes.
All right. So, if we are clear on that, we are saying that to solve equation involving indices, takes note of the following. One, if a is equal to that and is equal to that, then we equate the powers. And this law is only applicable if they have the same base. That's why we are saying that to solve, to express them, both sides of the equation with a common base, and simplify. How do we simplify? By equating the powers. By equating the what? The powers. So the first question, let's go to examples. Let's see how we go about that. Solve for x. Is not on the screen, please. Is not on the screen. Solve for x in the following equations. Solve for x in the following equations. A, I have 4 to the power x equals to 16. B, I have 2 to the power x equals to 1 out of 8. C, I have 81 to the power x equals to 3. Then D, I have 2 to the power 2x plus 1 is equals to 32. Okay? Members, are we together?
Yes.
So let's start with A. Let's work on them very fast, please. Let's work on them very fast. So, looking at what we have said, we said first to solve them, they must have the same base. They must have the same what? Base. And once they have the same base, then we can equate their powers. Are you together?
Yes.
So we have 4 to the power x equals to 16. When you look at this question, do they have the same base?
No.
Here we have 4. Here we have 16 also.
Yes.
Yeah.
So when you look at this one, which one can we simplify to have the lower base? The lower base in this case is what? 4. So we have to simplify 16 to have a base of
4.
So which one is that? So 16, then you come and say, but 16 is the same as 4 what?
Power 2.
I think that.
Yes.
So in that case, now they have the same base. So we shall say it implies now 4 to the power x equals to 16, which will be 4 to the power x equals to 4 to the power what? 2. So they have the same base. What do? We equate the powers. So what is x? Therefore, x is equals to? X equals to what? X equals to 2, right?
How?
They have the same base. We equate the powers. Okay?
Yes.
Yeah. Our purpose is to make them have a common what?
Common base.
A common base. So when you see that they have the common base, now once they have the common base, we equate their powers. Are you together, members?
Yes.
Now let's go to B. Let's look at question B. In B, what do we have? We have 2 to the power x, not so. Equals to 1 out of.
Excuse me.
Yes. Yes. So we have 2 to the power x equals to 1 out of 8. So when you look at this, the only number we can simplify to have a lower base is 8. So we shall have, when you come and say, but 8 is the same as 2 to the power. 2 to the power what? 2 to the power 3. Who is this one? There's a person murmuring here, please. Can you mute your microphone? Let's mute our microphone, please. Good. So we have few minutes remaining, please. We have only 10 minutes. So let's try to be faster. So now we shall have 2 to the power x, which is equals to 1 out of 2 to the power 3. But remember, we said that our purpose is to make sure that they have the same base. So when we recall, if I have a to the power negative n is the same as 1 out of a to the power n, and the reverse is true, right? Which means this one is going to be, which means 1 out of 2 to the power 3 will become 2 to the power negative 3. If that is true, if we remember that, so which means we shall have, it implies now 2 to the power x will be equals to 2 to the power negative 3. Now you see here, they have the same base. The base is 2. The base is what? 2. Therefore, our x is equals to negative what?
-3.
-3. Are we together on that? Let's look at C. Let's look at C. In C, we have 81 to the power x is equals to 3. Is equals to 3. Now, this time, which means the lowest base here is what? The lowest base is it? The lowest base is what? 3. So we have to make 84 to have a base of 3. But we know that 81 is the same as 3 to the power what? Is the same as what?
4.
3 to the power 4, which means now we can come here. So I have 3 to the power 4 raised power x equals to 3. Now this one we apply the power law. They have the same power. What do we, I mean, a number is raised to another power. We shall multiply the what? The power. So which will give us 3 to the power 4. 4x equals to 3 to the power. This 3 is the same as 3 to the power
1.
1. So now you see that they have the same base. So what do we do to the powers? We equate the powers. So equating the powers. So when we equate the powers, we'll have 4 what? 4x is equals to
1.
1. So what is x? What is x?
1 out of 4.
1 out of 4.
X is 1 out of 4. Just like that. Okay? Let's go to D. Let's go to D. Let's go to D. What is the question D saying? It was what? 2 to the power?
2x plus 1.
2x plus?
2 to the power 2x plus 1.
Plus what?
1.
Plus 1 is equals to?
32.
32. So which one are we going to simplify here? We are going to simplify 32. 32. Then you come and say, but 32 is the same as, we want it to have a base of 2. Is the same as what? 2 to the power?
5.
2 to the power 5. So it implies now 2 power x plus 1 equals to 2 to the power what? 5. Have you seen that? They have the same base. They have the same base. We equate the powers. So this one, it implies now we shall have 2x plus 1 is equals to? Not so.
Is equals to 5.
So 5 minus 1. So 2x is equals to?
4.
4. Divide also by 2. Divide also by 2. So our x is equals to?
2.
Is there any question on that? Really? Is there any question on that?
No.
Okay.
So can we go back on part C?
Part what? Part C. What was the problem in part C? Part C is here. Yes? Someone was talking about part C.
Yes.
What's the problem there? Huh?
On 3 power 4x is equals to 3 power 1.
Where is the question? What is the question there? Yes? Okay. We know that 81 is the same as 3 to the power of 4. Then 3 is the same as 3 to the power 1 because we want to express them in power forms. Okay? There's a silent one up there. There's that silent power there that we are not writing it. Okay? So that's why we brought it here so that we can equate their powers. Okay?
Yes.
Yes. Now, we have 4 minutes remaining. Work out for me this E. I have 3 to the power x plus 1 is equals to 243. 243. Can you simplify for me that? Members, work out that. I'm waiting for the answer.
I've got the answer, teacher.
Yes, who is that?
Malukenge.
Yes, Nalokenge, huh? What did you say? You started by simplifying?
Yes.
Simplifying what? Simplifying 240?
243.
Is the same as? In indices
3
form?
to the power of 5.
Is the same as 3 to the power of 5. Good.
3
To the power
power
x plus?
x plus 1
Equals to?
is equal to 3 to power 5.
What do we do from there?
We equate the powers.
Which will be?
X plus 1 is equal to 5.
So therefore, what is x?
X is equal to 4.
X equals to 4. Excellent, 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 excellent. Now look at me. Guys, today what have you eaten? If today you are so bright.
Ocean beans. Grains.
Girls today they are so bright. Okay. Members?
Yeah.
Exercise. We have 2 minutes remaining, please. I want to hear those who are saying that, teacher, we have not got the exercise. Number 1. Solve for the value of n. Part A. I have 5 to the power 2n plus 3 is equals to 125 to the power n plus 5. Okay? B.
Yeah.
I have 0.5 to the power n equals to 8.
Your camera is freezing.
My camera is okay. My camera is okay. Maybe yours. And our time is almost getting done. Please, can you put the work down very fast? Then number 2. I have 5 to the power x plus 3 equals to 25 to the power x. Okay? Have you seen those two questions? Have you seen those 2 questions?
Yes.
Do them and submit them before sunset. I want them to be submitted before sunset.
Okay, teacher.
Yes, should it clock tomorrow? Should it